Well, hello everyone. Thank you to the organizer for inviting me into this nice location. And I'm scheduled to talk about testing tools, right? So usually it's, and you talk about testing is enough to put people to sleep. That's why I'm early in the morning, so you don't fall asleep. I come from Boston, and I do work at Cypress.io, and the question you're asking yourself is like, can I get one of those t-shirts? And like, I have a few t-shirts. Come by later, tell me a good story, maybe I'll give you a t-shirt. We don't know that. If you want to find out like my projects, talks, blog posts, just do npx gleb. npx is a great thing, and I snapped gleb. And these slides will be at slides.com/Bahmutov. I've been doing a lot of different languages, but finally I arrived to JavaScript after a long journey. And now I mostly program JavaScript for Node.js and various integrations. Okay. So Cypress.io is a small company. We are based in Atlanta, Georgia, and we're making a fast and reliable test runner for anything that runs in a browser. And the best is that that's completely free. It's actually available on GitHub. And if you have your laptop open, which you should close now because it's important, just go to GitHub, give it a star. Okay. So I was looking at the jsnation.com website, and if you're like me, you're probably browsing with your DevTools open at all times, right? Because you never know. And I've noticed something by not noticing it. Do you see it? I'll give you a second. Do you see it? No? There are no errors. Like the console just stays like empty. And then I went to, who is from Netherlands here? Okay, so I went to your favorite newspaper, right? And it's just like, there's a message hi. Someone left console log hi there, which is kind of nice. Right? So, yeah, so what do we do? The first thing, if you don't have a crash reporting service installed on your website, web app, like just stop everything, stop listening, go and do it right now, right? You will open yourself to absolutely excruciating world of pain because you'll discover that your website or your web app is absolutely broken. You just didn't know about it. You should install crash reporting for everything that you write. It can be web application, server-side, API, serverless. I don't care what service you use, but just do it right now, because you have to know what's going on. So in World War II, there was a famous story where they looked at military aircraft that came back from the mission, and they looked at bullet holes, right? And they analyzed, and like, okay, so all the red dots are where we found bullet holes, and all the rectangles is where we never find bullet holes when the airplane flies back. And they like figure out, wait, if you get shot into one of those rectangles, your plane actually goes down, it doesn't get back. So the crash reporting can tell you, all the places where if there's an error, it survives, but also all the places where if it crashes, the user just doesn't get what's happening. So it's nice to have crash reporting, but there's one little problem, you're still losing airplanes. You only find out about the error after the fact. And JavaScript being JavaScript, it crashes all the time because, let's admit it, we're not the best developers. So instead of reacting to the crash, like to the user's problems, we should prevent them. And the best way to prevent it is to actually test our application before we deploy. There are a couple of different types of tests. There's a pyramid, and at the bottom, there are a lot of unit tests, right? Where you take a little part and you kind of inspect it and make sure that code does what it's expected to do. At the very top, you have end-to-end tests, right? You have usually no end-to-end test, or very few, because the tools are not there yet. But the purpose of end-to-end test is to simulate the real user. That means opening a real browser, not its emulation. Loading the actual application, maybe from localhost, maybe from staging, but opening the real thing as it is. Interacting with that thing as if a human user actually used your application. That means no clicking on hidden buttons, right? Scrolling to the text before you actually assert that the text exists. And then actually seeing if your application performs the way you think it should perform. So I think the end-to-end test should be really, really important, because they are very important to your users. It's still fine to write a lot of unit tests, because as a developer, I check my code using unit tests. But I think if you want to have your end-to-end users, end users, good experience, you should write end-to-end tests. Okay, so how do you write end-to-end tests? If you're like me, you do npm install Cypress. Well, or you download Cypress application if you just want to try it out. We build it for every platform, so you can just download, install globally, run it, see how it goes. We're even now building a Docker image with Cypress pre-installed, so you have no excuse. I had a quick question. Who has tried Cypress before here? Oh, nice, nice. You're my people, right? So people who have not raised hand, like turn to your neighbor who has raised hand and just hug them, right? This is a good, anyway, love early adopters. Okay, I'm going to show, here's how a Cypress test looks, right? And let me just start live coding. So I have a little application, and by law, I can only show to do MVC, right? I cannot show anything else. So I can add items. I can mark them as complete. I can say, completed, clear completed. That's it. Very simple. My test, and let me zoom in a little bit, looks like this. It should be pretty readable. Everything is chained over global sci. So sci visit opens, whatever I define in my configuration. And then I'm trying to find an element with class new to do and type a couple of things, just like a real user. And once I typed a few things, then I'm trying to find all the to-dos in the list, and I'm making an assertion that there should be 3 items. So I have application running, and I'm going to open Cypress. Cypress is the Electron build binary for every platform. And so it looks like this. It just shows me that I have a couple of test files, and I have a first spec, which is the spec we've just seen. What you see on the right is my application just being iframed. Speaking of previous speaker, we do strip all protections. We strip content security policy header, we strip X-frame protections, because you're testing your app. So in order to iframe, we have to strip a couple headers. On the left, you see the log. And you see that I'm visiting the website. I'm trying to find the element with particular selector. I'm typing right code. Then I'm typing more. Then I'm finally finding to-dos. And I'm making assertion. It's one-to-one mapping to the code I had in my spec file. It follows Mocha syntax. Another thing, if I hover, you can see it highlights the element that, for example, it found. So I can see that I'm typing into the right element. If I hover over type, you can see that it starts alternating. It starts showing before and after, because Cypress runs in your browser. It noticed that the DOM has changed after the command. So it shows you how the app looked before and after. There is a time-traveling debugger that just keeps all the snapshots. So I can see how my application behaved. When I was trying to make an assertion that there are 3 items, I can see the items highlighted, that's the items it found, and then passed an assertion. And then my test finds first item and clicks the checkbox. And then it asserts that the first item now has a class to do. Or completed, I'm sorry. So that's a typical Cypress test. Okay, so back to a presentation. Mocha syntax, every command, it should be very, very readable. Because you already spent all your mental cycles writing code. You all are very smart people. Some of you are geniuses, right? You don't want to spend cycles writing tests. The test should be as simple as possible. Okay. Now, the second thing you want to do is not just write tests like I did and run it in interactive mode. You want to run it on every commit, on every pull request, on your continuous integration server. So we have a lot of examples. It's easy to write end-to-end tests and run Cypress on CI. But the simplest thing right now is to use Circle CI orbs. Orbs come from central repository. Think of NPM, but for CI configuration things. So I've written cypress-io/cypress. My users, in this case, can just import it by version and just use a command. No more fiddling with YAML files, config files. And then I have my tests running on CI. Every commit runs end-to-end tests, generates video, screenshots on failure. That's it. One common thing is that people are like, well, I have to start my application, I have to build it first, and then I have to run end-to-end tests. So we've written a utility called start, serve, and test. So you don't have to write the CI snippets to start one thing, run the test, shut down your server. Finally, I have a peace of mind. I've written my test, I know my feature works, I run it on CI on every commit, I know no one's going to break it. But the question always comes up, do I need to write more end-to-end tests? Have I tested every feature of a program? Am I writing tests that only hit the same thing over and over? Did I test adding items 100 times and never tested anything else? So let the code coverage be your guide, right? And I'm not saying try to reach 100%. Maybe it's too much effort and ultimately not worth it. But the point here is that you will see some of the missing things. So in this case, I want to introduce a couple of my old friends. One is Istanbul.js. It's a library, has been around for a while. It does code instrumentation to collect code coverage. It's named Istanbul after the after the city in Turkey that's famous for its rugs. Code coverage covers your code, rugs cover your room. So Istanbul is a library. It has a CLI called NYC. They kind of follow that city name theme, so it's I don't know. There's also a Babel plugin. So if you use Babel to transform your code, you can just drop it in, and your code will be instrumented. Okay? So here's how it looks. I can run a command npx nyc instrument and give a source folder and output folder. And if I look at that folder now, all my code will be slightly weird. Well, it has all these extra things. So basically, it just inserts a bunch of counters. And if I run my application and I open my code, because I usually don't like instrumented code, I like to instrument on the fly, there is an object called coverage. Let me just zoom in. So my instrumented code keeps all the counters, as you can see, like functions, statements, how many times each statement has been executed. Okay? So if I keep running my code and exercising my application, all these counters will be incrementing. So in this case, statement 0 has been executed once, statement second statement was executed twice, but the fourth statement never ran. Okay? So how can we use this information in our tests? Well, I have this coverage object, but somehow I have to keep track of this after each test. Somehow I have to save it and generate a report. So we created something called Cypress Code Coverage Plugin. If you instrument your code as a pre-built process or on the fly using Babel plugin, then this plugin, by being added to Cypress, will save that information, and you'll see what parts of your code you exercise during tests. So all you have to do, add those 2 lines in your test files, and here's what happens. So I'm going to start Cypress again. Here. And remember, I'm just going to run a single test, the one that we've seen. And that test only adds a couple items and then marks one item completed. Very simple. A simple user story. Well, it turns out that the end-to-end tests are really, really effective at covering a lot of code, even in a simple user story. So this plugin already generated for me a coverage report in human format. So it's a static folder, and it contains HTML, and this HTML shows that even a single test covered 76% of my application code, of all the statements. A single test. Most importantly is that I can drill down into each folder And I can see where am I missing? What did I miss? So for example, the components were tested at 84%, constants at 100%, right? They were just loaded. But my reducers were only tested at 50%. So let me drill down, and I can see that there are a couple of files in that folder. And this particular reducer, to-dos, was only covered at 41% by my single end-to-end test. And here's, you can see that this line has been executed once. This line in a reducer switch statement was executed 7 times. And now I can see that my reducer has different actions. The actions with green, like add, were covered by the test. The test actually hit those lines. And because my test added 3 to-do items, this particular switch statement was executed 3 times. My test also marked a single item completed, so it was executed once. And now the question is, well, which parts did I miss? Well, all the parts in yellow are the switch statements that were never hit. So I never deleted a to-do, I never edited a to-do, or completed all, or cleared completed. So what do? I just write end-to-end tests to hit those lines, right? I need a test to delete to-do, or edit. So instead of this test, I have this full spec. And a full spec is kind of our typical end-to-end test. So in this case, it will add to-dos, edit them, mark things completed, and delete all completed items. So you can see the tests are just running there by themselves. And now it's done. So now, if I go back to all files, I got pretty much 100% code coverage from my end-to-end tests in 15 seconds, right? There is one tiny bit of problem, and you probably can see this, right? Everything was hit at 100%, except this particular file. Let me just zoom in so you can see it. It's a little selector. There is a switch statement. And it's just like, which to-dos should I show? Should I show all to-dos, completed? And there is a default statement that just throws an error because, well, that's invalid label. And you see the problem, right? Because it's hard to get to that particular line from end-to-end test. Because the way you've written your application, this case should never happen. But of course, we always put additional safeguards and additional lines of code to prevent basic errors that can creep in if you refactor something. So what do we do in this case? Well, the way Cypress works is that it iframes your website right here. If you do site visit, it loads your website. Your website is running instrumented code. If we want to test just this part, where is my selectors? Selectors. If I want to test just this class by itself, right, and reach that point, I cannot use end-to-end test. Well, guess what? Cypress can actually do unit tests for you. So in this case, I can import that particular selector function directly from my test and run a test to make sure that it throws an error if you pass an invalid visibility filter. So in this case, I can run just selector spec. And in this case, it doesn't load the website, nothing, but it does test my function. Okay? So if I combine all my previous tests with this one, I will get 100%. Okay? So I will just run all specs. Now, I'm not saying that everything has to be covered at 100%. But I think combining unit tests and combining end-to-end tests should be enough to give you close to 100%. Also, another thing that Cypress can do is, with the code coverage that it saves, you can forward it to other services. And then, when you do a pull request, then both services can tell you, did you increase code coverage or did you decrease it? Maybe you accidentally removed a test. Maybe you added a feature but did not add a corresponding test. So now it becomes not a question of hitting 100%, but a question of, did you add a feature without testing it? Or did you refactor code and all tests are no longer actually covering it because they used to cover it accidentally? Let me continue with presentation because I want to show something else. If I'm really evil and I come to my application and I go and I remove my CSS, what do you think happens? Let me just go back to this for a sec. Well, the test actually still passes because the test is functional, right? I'm only checking if I can enter something into input box, if I can mark items as completed, and if the text appears, right? It's not visual testing. It's only exercising the application as if the user were working with input buttons, with text, nothing about the style. So what do you do to prevent this? And it's kind of extreme case, I agree. Usually people just change padding, margin, and then all of a sudden it propagates and something else becomes broken. So people started adding lots of assertions into functional tests. And please don't do it. Especially don't try to test an element not to have a class or not to have like font size larger one. It's impossible to test against all the things that could potentially be broken. So instead of functional testing, or in addition to functional testing, you should apply visual testing. And in visual testing, the concept is that you have a baseline that's a good image that you approved, saved somewhere, and then when a new image comes, let's say from a pull request, you compare the new image to the baseline image, and you see the difference. And then you make a decision, is that what I wanted to do? Or is this accidental change and should not be merged? There are a lot of challenges with visual testing. Well, first of all, it's hard to get the app into complex state before taking an image. With Cypress, it's not that difficult. The performance is actually a huge problem because if you're taking a lot of snapshots and you're starting comparing them, your tests actually become much, much slower. It's hard to get the browsers running on different platforms to always generate consistent images. With fonts, everything. And just like, what's your workflow? Are you going to save all the baseline images in different resolutions for different browsers, all in your repo as binary files and check them in? It becomes a huge hassle. So there are lots of options how you can add visual testing to your functional testing. We have a bunch of plugins that users have contributed. Some of them are open source, some of them are third-party services. You can find them all online. And you have to make a decision for yourself. Am I using a do-it-yourself plugin where I care about the baseline images, I do the comparison using a plugin, I store the images, I kind of do everything, or do I use third-party service? I would suggest that you start with third-party service. They all offer free plans, you can try it out, you can use it for free for a while, or even like every month if you don't go over the limit. And then it's not that expensive. So try to use third-party service first. But what do I know? I just have a PhD in image processing, and I would not do it myself. I would just outsource it. So I want to show something from a service called Percy. So here's how it looks. I have a test right here. Where's my visual spec? It looks exactly as the previous test. Only in some places, I have this additional command that comes from Percy plugin. You install Percy npm plugin, and you get this new command. And what it does is that it names the snapshot, but it doesn't actually do the local thing. If I run my tests locally, this visual spec, it will notice that, well, there's no Percy, right? So it will just skip it. On CI, I have Percy token. It can actually send results to the Percy service. So if I take this particular broken case right now, and make a branch. Oops. No style. And I push it to my GitHub repository. And I open a pull request. I'm relying on so many external services during this demo, it's not even funny. Okay, so I'm creating a pull request. A pull request usually runs Circle CI, my functional testing. Okay. Meanwhile, while that thing is happening, I just want to say that the pull request workflow has been something we really, really like. Right? We don't want to have all the information thrown at us immediately, right? Because it takes time. So instead, we really like this idea of registering a service, and then when the pull request review time comes, you actually see, oh, is my security okay? Did I introduce any breaking functional tests? Did I introduce something else? So let's see if this works. So my tests are still running. Let's see the details. I have less than 3 minutes, so it better. Okay, it's doing install. Okay, installation. So I'm only running functional tests right now. Verified, saving cache, all the jazz. But those functional tests on Circle CI will kick off everything else. After they finish, they will send code coverage information to third-party service. So I will know if I accidentally decrease code coverage. It will also send the DOM to Percy, and Percy will recreate images, will tell me if anything has changed visually, not functionally. Okay, so right now the tests are running. So what you see here are just output from Cypress running in headless mode. Okay. So running all the little tests. Cypress doesn't depend on a framework, so it doesn't care like how you implement your application. It only goes through standard browser APIs like DOM, network, etc. So right about here, okay, Visual Spec runs. Okay, so okay, all good. Notice that a new check has appeared. Now Percy is actually creating those images, comparing it against the baseline images, and it will tell me if anything has changed. My functional tests have passed. But there are 2 visual changes, so let me actually look at those. You see all that red? I can click on the image, and I can see right here was my baseline good image that I have approved before. On the right, I see the new image that was just generated, and if I click, I can see in red the difference. So immediately I can see in different resolutions how my app has changed. And now I can decide for myself, is it something that I want, or is something broken? So we really like this pull request where first you run the test, and then you collect additional information, and then you can make a decision. So soon we'll have a GitHub integration for Cypress itself. I really want to release it right before the conference. Didn't happen, but it's coming. It will actually give you all the functional test results in a single thing. So I showed a couple of things that I think work really, really nicely together. Like Lego pieces, they just snap and they complement each other. The functional test is something that Cypress does. Visual testing, you do it yourself or use third-party service. Code coverage is excellent to actually guide your test writing. And finally, if you don't have crash reporting, you should install one now. Get a little bit scared, write more tests, and then it will stop. By making friends where you find tools that really complement each other, you actually will sleep better at night. And making friends doesn't mean that every other tool is your enemy. You just find tools that play really nicely together. Thank you very much. You can find the slide. Thank you.
Thank you.